On page 123 of your textbook, we began section 2.7, which discussed the absolute value function and several different types of transformations. We discussed reflections, so x-axis reflections. We discussed stretches and shrinks, as well as shifts. All right, so this is our parent function, y equals the absolute value of x. And it always begins at 0, 0 at the origin and goes up 1, right 1, up 1, right 1, up 1, right 1 on the right side of the graph, and up 1 to the left 1, up 1 to the left 1, up 1 to the left 1 on the left side of the graph. So here my slope of this part is 1, and here my slope of this half of the graph is -1. Right? If you are to create a t-chart, which you are more than welcome to do for any of these, you can plug in some values, -2, -1, 0, 1, 2. Find the absolute value of those numbers when you substitute them in, and have several points to plot. And once you do, you then have your parent function. So with these transformations, we discussed that there were 3 places we could put numbers. We could multiply the absolute value by a number a, we could insert a number h into the absolute value, or we could simply add or subtract a number k on the outside. So the following couple of seconds of this video, I'm just going to scroll through my notes as I read through them. So A discusses a couple of different things, whether it opens up or down. That is purely whether it is less than 0, so if it's a negative number, then it is going to open down, which is called an x-axis reflection. So that means instead of looking like our regular V, it is going to be turned upside down and reflected over my x-axis. So here is an example in blue to the left. This is just your simple x-axis reflection of y equals negative, or the opposite of the absolute value of x. So when a is -1, then it just simply turns over and flips over our x-axis. And we can plug in values for a t-chart, and of course always find some points and connect the dots for our graph. So when a is positive, that means it opens up, and it also affects our shrink. So it affects the slope of the lines that create our absolute value function. So if the absolute value of a is less than 1, that means it's a vertical shrink, which means it does get wider. Alright, so it should look more like this, a wider V, instead of our nice and sharp V. It should be a little less sharp. Alright, and if the absolute value of a is greater than 1, so if it's something like -3 or 7, then that's going to be a vertical stretch, which means our graph will become more narrow. Whether it is more narrow when it opens up or more narrow when it opens downwards, it is definitely going to be a thinner V than our parent function. Alright, moving forward, h and k affect shifts. So if h is positive, if h is greater than 0, we're going to shift right. And here's a couple of examples below. So if you see x minus 3 or x minus 1, that means h is equal to a positive 3 and h is equal to a positive 1. Because inside, it should be x minus h. So if it reads x minus 3, you actually replaced h with a 3. A positive 3, that is. If h is less than 0, that means on the inside becomes a positive, so you should see a plus sign. So if x is plus 2 is on the inside of my absolute value, your h is actually -2, which means I shifted to the left 2. Similarly, if k is greater than 0, that means you're shifting up, and if k is less than 0, you are shifting downwards, and you can see a couple of examples below. Now I'm going to go ahead and graph with you a couple of more specific examples that combine all of these transformations. for every single one of these examples, I do already have my parent function, so I can see how it transformed, how it has been transformed. So first and foremost, I want you to identify your A, your H, and your K. So A, it should be the number right there. It is hidden, but it is a 1. So when it's hidden, that means I'm multiplying by 1, so I don't need to write it. My H, since it should be x minus h on the inside, I actually replaced h with a positive 2. And my K is a positive 3. So H comma K is my vertex, is my new vertex. So I have shifted my entire graph to the right 2, so this means right 2 and up 3, so right 2 and up 3. So this is my new vertex. And my A being 1 means on my positive side, on the right side, I'm going to go up 1, right 1, up 1, right 1. And on the left side of my graph, I'm going to go up 1, left 1, up 1, left 1. Since A is positive, since A is greater than 0, I know it should open upwards, and it does. Alright, so this one simply shifted right 2 and up 3 with my vertex at 2, 3. That's my vertex. This graph is fairly similar as far as it just deals with shifting, so I'm going to ask you to identify A, H, and K and what those numbers do. So A is still 1, so I'm not vertically stretching or shrinking. It does mean that I will open up words. H is actually a negative 4 here. H is negative 4, and K is also a negative 2. So that means I'm going to go left 4 and down 2. So that means my vertex, instead of being at 0, 0, is going to be at negative 4, negative 2 this time. Negative 4, negative 2. And since A is still a positive 1, it opens upwards with the same slope of positive 1 on the right side and a negative 1 on the left side. Now let's look at an example where there is an additional stretch in reflection. So here, A equals negative 2, H equals positive 1, since it should be minus on the inside, and K equals a positive 3. So give me a second, and I'm going to draw on my parent function, and then we're going to list what A, H, and K do to transform our original graph. Alright, so since A is negative, since it is less than 0, that means it is going to open downwards. So this is our first x-axis reflection. So it opens down. Alright, and since it opens downward, so it not only is going to have it open downward, it's also going to vertically stretch it. Alright, by a factor of 2. By a factor of negative 2. So, since it opens downward, instead of my right side being a positive 2, it's actually going to be a negative 2. Alright, and the left side is going to be a positive 2. So that's just what the A does. Now the H, it means that I'm going to be shifting my vertex right 1, and the K, since it's positive, is going to be up 3. So, I'm shifting right 1, and then up 1, 2, 3. And I'm going to keep that negative 2 slope on the right side and the positive 2 slope on the left side. So it should have made my graph a little bit more narrow as well. Alright, and of course, to double check yourself in the transformation, you can always plug in some points. Such as after you figure out your shift, you could plug in 1 and know that your vertex is your highest point at 1, 3. That's where you get those values from. And then you can pick a couple of points on either side. Now for an example with a vertical shrink. So y equals 1/4 absolute value of x. A equals 1/4, h equals 0, and k equals 0. So that means I'm still centered at 0, 0. However, I do have a vertical shrink, since it is between -1 and 1, since the absolute value of a is less than 1. So what that means is my new slope on my right side, it does open up, is going to be positive 1/4, and I'm going to go up 1 into the left 4 as well. So since it is a vertical shrink, that means it should have gotten wider. And that's true. I can create a t-chart here and figure that out. I can plug in 0 and get out 0. When I substitute in the value of, let's say, 1, so I know for my parent function, when I take the absolute value of 1, it should be 1. But when I substitute 1 in here, you get out 1/4. So vertically shrunk that point down from 1, 1 to 1/4, and this is what's happening. It's vertically shrinking this entire graph down by a factor of 1/4. Alright, if you have any questions on 2.7, please feel free to see me in the morning or send me an email.